The best of the Bill and Corey Show.
Wow, that's a really good background we got there. Even green screen.
Oh, yeah.
Okay. Looks real.
It does.
Nothing's going to fall off the shelves. So the first question, sometimes I just ask Corey to answer this. It's a Corey question, but this is, here's the question from the customer. Is there a dual stage regulator model that has a maximum interstage pressure of 200 PSI? We plan to set these regulators to a maximum of 100 PSI second stage pressure. That's your delivery pressure. So here's a two-stage regulator, and this is Corey.
Well, so the customer was initially asking a lot of questions about dual stage regulators, and ones that were, I thought, pretty interesting. Like, what happens if you put a gauge on the interstage port? What would it show you? And I said, well, just show you the interstage pressure. And for our regulators up to 250 PSIG delivery, it's about 360. Interstage pressure is about 360 PSI, and if it's 500, delivery pressure goes up to about 560 PSI. Now, typically those are just set in stone because the whole purpose of the interstage regulator is to minimize supply pressure effect, which as the cylinder pressure goes down, there's less, forcing itself through essentially, and
the delivery pressure
goes up.
It's a force balance.
Force balance.
I'll interrupt you a little bit. We have a great video that you can find on our tech support YouTube page about single stage versus dual stage, and we'll see the supply pressure effect. So when the cylinder pressure goes down, the delivery pressure will go up, and the dual stage kind of dampens that out.
Now, I need to go back to this customer because I have a few questions for them, because I'm trying to figure out essentially what they want the interstage pressure to function as, because the whole point of it is just force supply pressure effect, whereas it seems like they want to use it for something more, which, these are the things that have to happen when you are speaking with a customer to figure out what their needs are. But
now let's explain a little bit about supply pressure.
Yes,
effect.
go ahead.
So good rule of thumb, with a thumbs up, is that when you have a cylinder, for every 100 PSI pressure that the cylinder decreases, the delivery pressure will go up 1 PSI. So if you get a 22,000 PSI cylinder, you're looking like a 20 PSI increase if you don't adjust the pressure at all during the life of the cylinder. So this supply pressure effect, what interstage does is all that pressure rise occurs in that first stage. So the second stage won't see it. And it'll actually be a negative effect. It'll kind of go down instead of...
So putting it from 360 to 200 doesn't really get you anything. So it's a curious question, and sometimes, and it's it's a really good question, because why do I need a dual stage?
And now that could mess up your flow characteristics.
Yes,
too,
it could.
Because you need pressure differential. Because if you want to, you get a pressure drop.
And both the first and second stage are rated to bring the pressure down from, are rated to the cylinder pressure. So it's not like if the first stage fails, or if that were to happen, the second stage will take care of it just fine. It'll see that pressure, but then you might see the supply pressure effect.
Yeah, you'll get the supply pressure.
It'll just become a single stage regulator.
Yeah.
So that's all that happens there. So we still have some back and forth, but it was an interesting question, especially the one who was like, what happens if you put a gauge in there? I was like, nobody's ever thought of that before.
Well, we've done that.
I know we have, but it's just like...
We do that sometimes when we're doing flow testing or something. We might put a gauge in there and say, hey, what's happening there?
What's happening there? Yeah, no, it's just, no.
No, we do have an oddball dual stage regulator for ammonia.
Yeah.
Now, ammonia is a liquefied gas.
Low pressure.
Relatively 114 psi vapor pressure at room temperature, and the customer, we had one customer years ago that really needed this. So really, so I guess they were looking at when the pressure goes kind of empty on ammonia, and they had really sensitive instruments. So we set the interstage to 60 psi, delivery pressure of 30. So you get some pressure differential there to give you some flow. And it's really kind of a low flow application. They're just really super concerned about pressure fluctuations.
Yeah, and the flow is, so if you have dual stage is at the same pressure, you're not going to get...
Yeah, it's not really a terrible question. Where do you get the 7 SCFM for the flow rating on the 3810A and 3120A series dual stage regulator?
I know where you get it. You go to store.mathesandgas.com. You order one of these regulators, put it on the cylinder or bottle, as the kids like to say, and then out comes the 7 standard cubic feet per minute. That's how you get it.
Okay, so we're talking about, we had a customer call in. It was a dual stage regulator. I don't know if it was a 3810A or 3120A. They have the same flow characteristics. Little secret
just different
here.
materials.
One, the 3810A stainless steel, and the 3120A is plated brass, nickel plated brass. Same flow characteristics, just different materials. So yeah, so where do we get this from? Let's pop up the first slide. And then this is off our online store product page for the 3810A series regulator.
And the key word is the first word. That's
typical.
That is the key.
Typical.
Key word.
Yeah, typical. And we say that so that you get an idea. This is for regulator sizing. You're thinking, I need a regulator, I need about 5 CFM. You go, this will work. If you have a regulator that needs 10 CFM, you'll be like, yeah, maybe I should look at something else. Yeah. We picked 100 PSI. That's a popular delivery pressure. And it's kind of close to the other. You might be in a, 70 to 120 range. And it's like, yeah, I can kind of figure things out. You want to pop up next slide? Next slide. So these are flow curves. Mm-hmm. And if you look at them, they'll go, the 7 CFM is about 420 standard cubic feet an hour. And you say, wait a minute, these flow curves go way beyond that. What's the deal?
What's the deal with these flow curves?
What's the deal with these flow curves? Heck, I can get a 1500 SCFH. So what we do is companies can rate their flow rate however they want.
Well, I mean,
really, they can. So,
well, they can't just say it's 100 standard cubic feet per minute.
Well, no, you gotta. Well, whatever. No one's gonna buy it. Okay, you can kick off the slide. You see our wonderful faces. So yes, so they could rate it however they really want to do it. So the CGA, Compressed Gas Association, and publication E4, which is a standard for gas pressure regulators, they have their suggestion is, this is the rated flow capacity can be defined as 80% of the flow rate with the lowest inlet pressure at which it is to be used.
Yeah, so it's kind of giving a standard without saying it has to be a standard because there's no rhyme or reason why we would make it a standard. Right. That's what it seems like.
You can, because people are kind of all over the place, and there's different things going on with regulators. Mm-hmm. So you want to put up the next slide? You have to look at the slide, not us. So there we go. So this is the part of the flow chart, and you can see it's a 125 at 2,000 PSI inlet. That's like a full cylinder. Mm-hmm. And so there it's looking, I'm guessing about 520 SCFH is where it crosses that line. Oh, I'm looking at 125 PSI static delivery at zero flow.
Oh, there you go. Okay.
80% is like 100. So that's looking at 520. Well, that 520 is like 8.7 CFM. Well, the reason why we don't do that, it's supposed to be the lowest inlet possible. So you have a dual stage regulator, and it's going to kick it down from cylinder pressure down to about 350-ish. Mm-hmm. So the higher pressure, we'll show you what's happening. So yes, this is higher than what we rated at. How come we don't rate it at 8.7 CFM? So let's go to the next slide. Okay, so this inlet pressure is 200 PSI inlet. So that's really really as low as you can go.
Yeah,
your cylinders
at that point it's going to stop flowing. Yeah,
it's 10% of the full. Yeah, you don't have a lot of flow there. As you can see, we don't have the flow curve for 250 PSI in here because it's below 200, so it's kind of silly. So, so when you pick your lowest pressure, if you're trying to do this at home with your regulator company, you need really be below the below the interstage pressure.
Call your local regulator company.
Below your interstage pressure. So here, this chart was previously made for us at 200 psi inlet, so that sounds reasonable. In there, you can see 80% is lower. It's like 420. So that's why we rated it, which is 420 standard cubic feet an hour, about 7 CFM. So that's why we rate it.
We rate it at it's at a lower aspect of the flow rate. So this is, it's not the worst case scenario, but it's going towards the worst case scenario down that low in pressure. So there's nothing stopping you from saying, you know what, I want to stop flow, when it gets to 400 psig and I know my flow rate's going to drop below what I need it, I'm going to use a cylinder only to 400 psig and then somehow have some kind of system. So there's nothing stopping you from doing that as well if you need a higher flow rate. So
well, that's why we had the flow curve.
That's why the flow curve. So I'm just trying to explain it in a different way that might help people understand it, because flow curves I feel like are hard to understand personally.
Yeah, they